Stage 1 is initiated when a client shows serious interest in deploying the service and is activated prior to the signing of the contract. This is a technical assessment of the pipeline to establish if it is a suitable candidate for SCT inspection. It involves an evaluation of technical conditions, but also, and of equal importance, an evaluation of the terrain along the route of the pipeline. The next stage is to mark out the pipeline route using a pipeline locator. It should be noted that this operation takes a longer time to complete than does the magnetic scanning survey, and therefore we usually ask the clients to complete this operation prior to our team arriving on site. With the terrain now known and the pipeline route clearly marked out, we now undertake a topographical mapping survey to record the exact location of features above ground that may prevent inspection, cause interference, or be used as reference points to assist in the return after inspection to specific locations, should further investigation be needed. To achieve the best accuracy possible, we use a GNSS positioning system that communicates with the US GPS and Russian GLONASS satellites, and is programmed to communicate with the European Galileo and Chinese satellites when they too come online. The system is triangulated with a base station communicating with satellites and a rover which also communicates with satellites. Activation is controlled by the operator using a data logger with Bluetooth connections, and the coordinates of every feature that are mapped out are recorded on the same data logger. Following completion of Stage 3, the team returns to the field base and assembles the magnetic data scanner we call Uniscan. This is easily portable and consists of a carbon fiber frame, which carries the magnetometers, control units, and rover GNSS receiver. When complete, it weighs 6 kilograms and is easily carried by a technician using a harness. As you watch the video, note how the frame is designed to carry the magnetometers at right angles to the Earth's surface, and the receiver is close to vertical. Having completed the assembly, the engineer uses the data logger to configure the rover to communicate with the Uniscan control unit, where it stamps its position onto the magnetic data at a rate of 50 times a second. With this operation completed, it is now time to start scanning. Following the flags marking the pipeline route, the technician carries the Uniscan, which silently and continuously collects and records the self-magnetic flux leakage data, which is in the order of 2 to 20 microtesla compared with the Earth's magnetic field of around 40 microtesla. The magnetic field, although low in intensity, is large enough to send a compass needle spinning in different directions wildly, if it were to be held over a particularly high, localized stress location of the pipeline. This data is collected at normal walking speed, and typically in a day, 4 to 10 kilometers can be covered, depending on terrain and provided the route has been marked out prior to the team arriving on site. Having completed the scanning operation for the day, the team, before leaving the site, checks that the data has been stored correctly. The instruments are then disassembled and packed and are returned with the team to their hotel. Data can then be processed in their room, on a laptop, or sent to the UK for further processing. Either way, it's possible to indicate to clients the next day if there are potentially dangerous conditions in any locations of the pipe which have been scanned the previous day. Processing is automated and fast, and 1 kilometer worth of data can be completed in 5 minutes.